This will be Geometry section, Chapter 4, Section 4. Today we are going to talk about the Pythagorean theorem. And as I have here, this is a huge subject in geometry. We're going to be using this in several different chapters, pretty much for the remainder of the year. Now, the Pythagorean theorem mainly deals with right triangles. The thing about the Pythagorean theorem is sometimes within triangles that are non-right, we can create right triangles. Like if we look at an isosceles triangle, we can cut the height down and we can actually create two little right triangles within there. But what we really need to do the Pythagorean theorem with is right triangles. So I need to discuss the parts of a right triangle. Now if we look at a right triangle, we have three vertices, A, B, and C. Now normally the way we do it is we label that right angle as angle C, and then A and B are interchangeable. Now if we look at this side, the side that is opposite of angle A, so here's angle A, the side that is opposite of that angle, we would normally call little a, and the side that is opposite of angle B, we would call little b, and then the side that is opposite C, we would call little c. Okay, so that's the way we normally are going to see these right triangles labeled. Alright, now, the parts of it, when we were dealing with an isosceles guy, these isosceles guys last class, we called those equal sides legs. This was a leg and this was a leg. And then this guy was a base. Okay, so we're going to have some of the same terminology today, but we're going to change that base side, and we're not going to call it a base. Okay, so if we look at this right triangle, the two sides that form that right angle, this side and this side, form that right angle, we are going to call those two sides my legs. So this is a leg, and this is an leg. So little a and little b are both my legs. Now C, this third side, notice that it is opposite of the right angle. That third side that is opposite of the right angle, we're not going to call the base today. Okay, so we're not worried about the word base. We're going to call that third side opposite of the right angle. That guy is going to be the hypotenuse. Hypotenuse is how you spell that. Now a couple things about that hypotenuse. Always opposite right angle. Okay, so it's always opposite the right angle. It's always across from that right angle. The other thing is it is always, if we have a right triangle, that hypotenuse is always the longest. It's always the longest side of that right triangle. Now mainly because one of the things we're going to do later on in this chapter is if this is my right angle, this is actually the largest angle in that right triangle. This guy would be acute, and this guy would be acute. So that's my largest angle, so that's the longest side opposite of my largest angle. So that hypotenuse, we need to know how to find that hypotenuse and which one it is. Okay, remember that hypotenuse is always the longest side, kind of a way we'll quickly check ourselves. So if we look at this triangle, what sides are opposite of the given angle? So here's angle A. What side is opposite of that? Well, we called it BC, but we're also going to call it little a. Okay, so if we go to angle B, here's angle B. What side is opposite of that? Well, that would be AC, segment AC, or we could also call it little b. And then angle C, the side that's opposite of that would be BA, or AB, I would prefer. Or we could call it little c. Okay, so the side opposites are something that I told you, you're going to see me draw those arrows a lot in here, and you need to be able to find what side is opposite of this angle and this angle. Right? So important things right there. A and B that form that right angle, those are called your legs. The side that is opposite of that right angle, this is probably the most important side, is your hypotenuse. It's always across from the right angle or opposite the right angle, and it's always the longest side. All right. Now the Pythagorean theorem. The Pythagorean theorem, if a triangle is right, so if we have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. So what that means is, if we go back to this guy, the legs were A and B, so the sum of the squares, meaning if I take the squares of both of those, and I take the sum of that, that's going to be equal to the sum of the third side squared. Right? So this guy right here is very, very important. Now I normally say box it, circle it, put a pretty little cloud around it. Well, I already put a pretty little cloud around that for you. That should show how important that is. Okay? So this is the Pythagorean theorem. It's the sum of the squares of my legs. A and B are my legs. Oops, I have this triangle backwards in the drawing, sorry. And it equals this square of my hypotenuse. I'm going to change this drawing a little bit. Let's make this guy C. So this would be little c. This guy could be B, that's little b, and then this would be little a, and this would be capital A. Sorry, I apologize for that, but that's the way the drawing should be. Alright. So what we can do is we can use this formula to find missing sides of a right triangle, and we're going to see lots of different places where we can use this Pythagorean theorem. Pretty much every chapter from here on out will use this. Alright, so let's see what we're going to do. Now here's the question I'm going to ask you. If you have two sides of a right triangle, how do you find the third side? Well, that's the Pythagorean theorem. So we know that we are going to use the Pythagorean theorem here. Right. Now, here's the trick. What we need to do, and what I would suggest you do, is you go through and you find every hypotenuse. Now remember, the hypotenuse we said is opposite the right angle. So this is a hypotenuse. Number 2, here's my right angle. That's my hypotenuse. What I think you should do right now is go ahead and pause the video and go ahead and circle every hypotenuse on each triangle. Now sometimes like this one, it's unknown. I don't know x. Now sometimes on like 5, 6, 7, and 8, I know the hypotenuse. So go ahead, take a second, go through there, circle all the hypotenuse. Alright, let's go on with number 1 now. Now number 1, we have my legs of 6 and 8. Now again, if I had my triangle labeled like before, it was like this. A, B, and my right angle is C, so this would be little b, this would be little a, and this would be little c. Right? So here's the trick to this. The hypotenuse is always going to be C. That hypotenuse is always going to be the C value. Okay? So if we went back to this, the hypotenuse is always labeled as C. Will always be labeled as C. Right? So if we go to plug in here, it's irrelevant which one we plug in, 6 or 8. So what I'm going to do is I'm going to go 6 squared plus 8 squared. If you did 8 squared plus 6 squared, good for you. Same thing. That's the commutative property of addition. Equals, now here, the C, the hypotenuse, is over here. So this is my C value. So I'm going to put X there. And if you wanted to leave C, you could. That's fine. Alright, so what I need you to do now is get your calculator, and you take 6 squared in your calculator. That's 36. Plus 8 squared, that's 64. We're going to take 36 plus 64 equals x squared. That's 100 equals x squared. Now you hopefully remember this from algebra. To get rid of a square, the inverse operation of squaring something is to take the square root. So we're going to take the square root of each side. The square root of 100 is 10, and that's your answer. So our length of this third side of the hypotenuse up here is 10. Now what I told you about the hypotenuse is that it's the longest side. So if you look at your triangle now, is 10 the longest side? Is it longer than 6 and 8? Yeah. This is a huge right triangle right here, the 6, 8, 10 right triangle. I'm going to start with this one. This is a huge one as well, 3, 4, 5. Now if I double each of those, I get a 6, 8, and a 10. So these are base right triangles that we're going to see over and over again. Right? Let's move on to number 2. So again, we have our hypotenuse right here. Remember, that's your C. That's your C value. So when we go A and B here, it's irrelevant which one we use first. So what I'm going to do is I'm going to go A squared plus B squared equals C squared, which in this case is X. If you wanted to leave it as C squared, that would be fine. That's 25. That's 144 equals X squared. That's 169 equals X squared. Again, to get rid of the squared here, we need to square root. Square root. The square root of 169 is 13. So that means your third side up here, the hypotenuse, is 13. Does that make sense? Is that my longest side? Yep, it is, and that needs to be the longest side. The hypotenuse needs to be the longest side. All right, I'm going to do the shortened version of this. I'm going to skip over 3 and 4. And you can do those on your own. Now on number 3, what's going to happen is you will get a decimal for this when you square root it. Please round to the nearest 10. Okay, so in my class, unless I otherwise specify, please round to the nearest 10. Alright, number 5 and 6. Now here's the twist on these guys. What we have here is I know the hypotenuse. I don't know one of the legs. Okay, I don't know a leg here. So what we're going to do is this one works slightly different. So let's set it up. Now again, remember my legs, it doesn't matter A or B, it's irrelevant. This is the guy that matters. That's your C. So we set this up. I'm going to set it up as x squared plus 18 squared equals my hypotenuse, which is 30 squared. Now we have to do it that way. That hypotenuse needs to be over there. So we take x squared. 18 squared is 324, and 30 squared is 900. Now this comes down to the basic algebra solve right here. I'm trying to get x by itself. I'm trying to solve for x. So what I need to do is subtract 324 squared. Subtract 324 squared. X squared is 576. And then now we square root it. So the square root of 576 is 24. So our missing side is 24. Now if we go back up in our drawing and let's look and see if that makes sense. Does it make sense that this x right here is 24? Well look, what's your longest side supposed to be? 30. Is that less than there? Yeah, so we're good to go. Okay. Same process of number 6. We went ahead and circled this. Our hypotenuse is 16. So when we set it up, it would be x squared plus 4 squared equals 16 squared. Okay, so we can go through and square all these. We have x squared plus 16 equals 16 squared is 256. We're going to subtract 16. That's Gandhi, so we have x squared equals, that's 240. So what we're going to do is we're going to take the square root of 240. Now we get a decimal here. The decimal approximation is approximately 15.4912. 15.491. That 9 rounds the 4 up to 15.5. And I'm going to put squiggles here. The two squiggles mean, hey, that's an approximate answer. I rounded it. So let's go. Does that look like it makes sense that this guy would be 15.5? This is 16. It's got to be less than that. So yes, we're good to go. All right. I'm going to skip 7, and I'm going to go on to 8 and look at 8. 8, we have the same process. Now what we should do is look right away. There's the right angle. Opposite that is my hypotenuse. That's your C value. Now if you notice on this one it's a little bit different. I have two x's. Okay, well that's okay. We'll work with it. We'll go x squared plus x squared equals my hypotenuse, which is 9.9 squared. Okay. Now we simplify this. If you look at this, what is 1x squared plus 1x squared? Well, 1x squared plus 1x squared is 2. X squared equals 9.9 squared is 98.01. Okay, so that's exact what that is. Now what we do here is we have two things to get rid of. What I would tell you to do is get rid of that 2 first. Let's get rid of that times 2 first. We're going to divide by 2, divide by 2. And x squared is 49.005. Now that .005 is so small, I'm not even going to write it. I'm just going to go 49. That's 49. Now we square root, x is 7. So what we have here is that this side is 7 and this side is 7. So we have a nice pretty right isosceles triangle. Okay, that's the Pythagorean theorem. And what we can do is we can use that Pythagorean theorem within the coordinate plane to find the length of a segment. Okay. Now, if it was directly up and down, let's say the distance from B to C here, well, that would be easy because all we would do is we'd go 1, 2, 3, 4, 5, 6. We would just count. We would find that length of 6. Same as if it was a nice horizontal line, say from here to here, we could just count. 1, 2, 3, 4, 5. That segment would be 5 units long. But when it's oblique slash slanted, when it's oblique slanted like this, we can't exactly do that. But what we're going to do is we're going to use the Pythagorean theorem here. So let me draw this back in here. I'm going to call this point right here C. Okay. Well, now if we look at that, that's 1, 2, 3, 4, 5, 6 units long. Okay. Now if we come down here and I go from A right along here to C here, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. Now, how could we do that mathematically if we are in the coordinate plane? This point right here, 1, 2, 3, 4, 5. This point right here is negative 5, 0. Now remember, that's an x and a y value. This point right here is 1, 2, 3, 4, 5, 5, 0. 5, 0 is my ordered pair for that. Now, if we look at this, now let's go up to this point. This point would be what? 1, 2, 3, 4, 5. This point right here would be 5. So again, if we look at this, we just simply counted to get those ordered pairs, and we just made up our new point right here, which is straight down, straight to the right. And if you know, that's a right angle right there. If you go vertical and horizontal, those are perpendicular, so that is a right angle right there. So we kind of created our own little um, right triangle right there. Now, if we look at this, how did we get this 6? Well, if we look at this, what we did is we went from 0 over here. Now, we're at the same height here, 0, up to 6. Well, what's the distance from 6 to 0? 6 minus 0 is 6. So that's kind of where we got that 6 from. Now, if we look at this guy, how did we go? We went from negative 5 to 5. Well, if you look, what's the distance? 5 to negative 5? Well, 5 minus negative 5 is 10. So that's kind of how we got that. Well, now what we can do is we can just simply do the Pythagorean theorem. We would go, all right, 10 squared plus 6 squared. Now remember, we got that 10 squared by taking 5 minus negative 5. And we got that 6 squared by taking, oops, wrong color, by taking 6 minus 0. Okay? And then that would equal whatever that AB is, whatever that side is, squared. Well, okay, well, what we're going to do now is we're going to go ahead and square root it, So this is your answer. So that's going to be the square root of 136. So if we take the square root of 136, we get 11.66, so approximately 11.7. Okay, so that means that this guy right here has a distance of about 11.7. Right? Well, now what we can do is we can actually do this without counting in the coordinate plane and count up 6 and over 7. And the way we do that is just what we did right here. What I did is I took my two y's, 0 and 6, and I subtracted those to get the 6. Took my two x's, subtracted them to get the 10. So here is the distance formula right here. Now I want you to jot this down nice, big, and beautiful. The distance between 2 points in the coordinate plane is the square root of, we're going to take our x's, take both my x's, subtract them, and then I'm going to square it just like I did here. And then I'm going to add to that, just like I did here, my y's, and I'm going to subtract those two guys, and then I'm going to square it. Okay. So here is the distance formula. You need to jot that down nice and big right on your sheet. Well, now we don't even need a graph to do the distance formula. If we're just given two points right here, A 0, 0, and B 6, 8, we could go back and look at the graph. Well, here's 0, 0, here is 6, 8, and we could actually just find the distance between these 2 points. Now we can't do it counting because it's oblique, but what we can do is use this distance formula to find the distance between those 2 points. Now, a lot of times, again, it is going to be a decimal, especially in coordinate geometry. But what we're going to do here is let's go find the distance between A and B. So the distance formula here, I'm going to jot the distance formula down again, is we're going to take x minus x squared plus y minus y squared, and then we're going to take the square root of that whole mess. Now, if you remember slope, I always had like a y2 minus a y1, and it mattered which way you subtracted. In this one, it doesn't, because if you subtract them, if you take 0 minus 6, that's negative 6, you're going to square it, it becomes positive anyway. And if it's 6 minus 0, it's positive, and it stays positive. So it doesn't matter which way we subtract in the distance formula here. Alright, so what we're going to do is we look at our points here, this origin right here, x 0, 0, the x value is 0 and the y value is 0. If we look at this guy, the x value is 6 and the y value is 8. So when we go to check this into our distance formula to find the distance between the 2 points A and B, we're going to take my x's. Now what I'm going to tell you to do is I'm going to tell you to do this in the easiest way you can. Now would it be easier to take 0 minus 6, my x is here, or would it be best to go 6 minus 0? I like this better, so I'm going to take 6 minus 0 squared plus, now let's look at our y's, 0 and 8. So what I'm going to do again is I'm going to 8 minus 0. Now notice I've kind of flip-flopped those. I thought using 8 first would be easier. So now we can go ahead and continue with our formula. Let's simplify some things. So 6 minus 0 is 6 squared. 8 minus 0 is 8 squared. Now I hope you're kind of starting to see the Pythagorean theorem right here. 6 squared plus 8 squared equals d squared. Well, we square root it. Now once we do this, what I want you to do is go ahead and take 6 squared plus 8 squared. Throw it in your calculator. That's 36 plus 64 is 100. And then you simply square root that. Now this comes out pretty, so square root of 100 is 10. So the distance between A and B is 10. So the length of segment AB is 10. Okay, let's do one more of those, and then we will be done. So let's go over here to the distance between points X and Y. So the D equals the square root. I'm going to rewrite the formula. Now on your homework, you do not need to rewrite the formula every time, but you do have to show your work. So you are going to need a separate sheet of paper to do your work for this assignment, or I will not give you points. So D equals the square root. My x values, here's an x, and here's an x. Now would it be easier to go negative 2 minus 3, or would it be easier to go 3 minus negative 2? I like this guy because when you subtract a negative, you end up adding. So I'm going to go 3 minus my other x value, which is negative 2, squared, plus, now we're going to go our y values. My y values are 5 and negative 4. So again, I'm going to do 5 minus negative 4. We're going to square it. Alright, keep bringing it down. So we're going to have 3 minus negative 2, which is a plus. So that's 3 plus 2, which is 5 squared. Plus, we have 5 minus negative 4, which is 5 plus 4, which is 9 squared. Right? Now again, what we can do is we cannot square root each of these separately. What we need to do is we need to take 5 squared, which is 25, plus 9 squared, which is 81, and that would be the square root. Now I don't care if you skip this step. You can skip this step right here and just put 5 squared plus 9 squared in your calculator. That's going to be 106. And then what you need to do is 106 is the square root of 106 is not a pretty number, so we do a square root of 106. It's going to be 10.2956, so we would say, alright, the distance is approximately 10.3. Okay, so there's your answer. It's a rounded answer, but the distance between the 2 points x and y would be 10.3. Right, now, on your homework, it will be Math Excel 4.4. And again, I need you to show work. You must show work on this assignment or you will not be very successful. You do your work on a separate sheet of paper and I will collect your work next class. Right? If you have any questions, please come see me and good luck.